I am Aditya Chakraborty, lecturer in electrical engineering of C. Ramakrishna Institute of Science and Technology. Today I am going to discuss about the part 5 lecture of boiler, steam turbine and steam engine. Now the first slide is about the steam turbine. A steam turbine is an engine in which the thermal energy of the steam is converted into mechanical energy of rotation. So when the steam is fed to the turbine, it will be rotating in mode and it drives any mechanical objects. In a steam turbine, the energy of the steam is transferred into kinetic energy by expansion through the nozzle. So by the help of the nozzle, the kinetic energy is converted into potential energy, and the kinetic energy of the resulting jet is in turn converted into force doing work on rings of the blades mounted on a rotating part, and then the turbine is in rotating mode. Now the operating principle of turbine. The steam turbine develops mechanical work by converting heat energy into work in the steam expansion. The heat energy is converted into two steps. The first step is the steam expands in nozzle and expands a high velocity, converting the available heat energy into velocity energy. And the high velocity steam strikes the moving blades. So at first the steam energy which is stored in the nozzle as a kinetic energy and is converted into high velocity, and high velocity steam strikes the moving blade, hence the turbine is in rotating condition, and then it converting the velocity energy into a work. Next, the advantages. The economical generation of high temperature and pressure steam is required to reduce the pressure to utilized for various purposes. This will be done by steam turbine, thereby developing power to run pump, etc. A pump driven by turbine can be operated over a wide speed range utilizing the turbine governor system. So by the help of turbine governor system, the steam pressure can be controlled, and by the help of the control steam pressure, the speed of the turbine can be controlled, and hence the pump which is driven by the turbine, its speed can be controlled. The use of the steam turbine driver permits operation of the driven pump is independent of electrical power or distribution system. So if there is no such electrical power is used, we can control the speed of the pump by the help of turbine. So though there is no motor is required for that operation, a turbine may be used as standby drive system. The steam turbine controls governor system and overspeed trip system are inherently spark proof. There is no such electrical equipments are used, so that is spark proof. Steam turbine are inherently self-limiting with respect to power developed. Special protective devices are not required to prevent damaging the turbine because of overload condition. So these are the advantages of steam turbine. Now the next slide is on the classification. Steam turbine are classified into 6 categories. Number 1, flow direction. Number 2, according to the way of energy conversion and type of blading, type of compounding, exhausting condition, number of stages, inlet pressure. So according to flow direction, that is axial and radial. According to way of energy conversion, that is impulse and reaction. According to type of compounding, that is pressure compounding, velocity compounding, pressure velocity compounding. According to the exhausting condition, that is condensing, extraction, back pressure, reheat. According to number of stages, single and multi-stage. According to the inlet pressure, that is low, medium and high. In our discussion, we are going to discuss the classification of steam turbine according to the way of energy conversion and type of blading. That is, number 1 is the impulse turbine and number 2 is the reaction turbine. So number 1 is the impulse turbine. An impulse turbine, there are some fixed nozzle and moving blades are present on a disc mounted on the shaft. Moving blades are symmetrical in order. The steam enters the turbine casing with some pressure. After that, it passes through one or more number of fixed nozzles into the turbine. And this nozzle converts the kinetic energy into potential energy, and hence it's supplied to the turbine blade. The relative velocity of the steam at the outlet of the moving blades is same as the inlet to the blades. During expansion, steam pressure falls. Due to high pressure drop in the nozzle, the velocity of steam increases. So according to the construction of the nozzle, so nozzle construction drop the pressure of the steam and increase the velocity. The high velocity jet of steam flows through fixed nozzle and strikes the blades with constant pressure. So an impulse turbine, steam produced only impulsive force to the blades or to the symmetrical blades. Now blades are starting to move in the same direction of the steam direction or the same direction of the steam flow. So due to changing momentum, the turbine shaft is starting to rotate. So this is the main funda of impulse turbine. Now this is the impulse turbine schematic diagram. Here you can see a bucket and stationary nozzle, and the steam is supplied through the nozzle, and the back part of the nozzle, the steam is stored as a kinetic energy, and the front part of the nozzle, the velocity is increased and the steam pressure is reduced, and it is fed to the symmetrical turbine blade of impulse turbine. So this is an impulse turbine. Here you can see a bucket and the blades are connected with the bucket. Now the second one is the reaction turbine. Here steam flows through the nozzle at the end of tubes and it is supported on the bearings. The outlet relative velocity of the steam is much less than at the inlet to the blades. So in case of reaction turbine, there is a reactive force or reaction force is applied to rotate the turbine. So here the steam flows through the nozzle at the end of the tubes and it is supported on the bearing for rotate. And the outlet relative velocity of the steam is much less than at the inlet of the blades. In a reaction turbine, nozzle will move on bearing in the opposite direction of the steam flow, and the pressure is not constant in the turbine. That's why a reaction force is always applied on the nozzle and the tubes, so that there are two types of blades. One is inner blade and another is outer blade in case of reaction turbine, and the steam rotate the inner blade first. After that it is fed to the outer blade, or the rotation of the inner blade rotate the outer blade also. In this turbine, steam produce both impulsive and reactive force. So the resultant force produced to the rotor is the vector sum of the impulse and reactive force. And the reaction force is unbalanced in condition. Generally the turbine is not used for commercial purpose. Due to this reactive force, it is called the reaction turbine. Now the reaction turbine image. Here you can see there are two types of blade. the inner blade is connected to the reactive or reaction force or reactive force, which is fed through a tube, and the outer blade is connected with the inner blade. The periphery of the outer blade is much more bigger than the periphery of the inner blade, and the steam is supplied through the nozzle, and this bearing uh, is connected with the nozzle, and hence the turbine is rotated by the help of the reaction force of the steam. Now the differences of impulse turbine and reaction turbine. In impulse turbines, the steam completely expands in the nozzle and its pressure remains constant during its flow through the blade. So, a constant pressure is maintained in impulse turbine. And in case of reaction turbine, the steam expands partially in the nozzle and further expansion takes place in the rotor blades. The relative velocity of the steam passing over the blade remains constant in the absence of friction. There is no such friction. So, the relative velocity of the steam passing over the blade remain always constant. The relative velocity of the steam passing over the blades increase as the steam expands while passing over the blade. In case of impulse turbine, blades are symmetrical, and in case of reaction turbine, there are two types of blade. One is inner blade and one is outer blade, so it is asymmetrical in nature. The pressure on both ends of the moving blades are same. The pressure on both ends of the moving blades are different, because at first the pressure is supplied to the inner blade and hence it is supplied to the outer blade. For the same power developed in case of impulse turbine, as pressure drop is more, the number of stages required are less. So a high pressure steam is directly fed to the turbine blade, so the stages are less required in case of impulse turbine. For the same power developed, as pressure drop is small, in case of reaction turbine, the impulse force or pressure is very small, the number of stages is required more. So there is two stages mainly required. One is at first the inner blade is rotating, after that the outer blade. The blade efficiency curve is less flat, and because the blade efficiency is high, and the blade efficiency curve is more flat in case of reaction turbine. In case of impulse turbine, the steam velocity is very high and therefore speed of turbine is high. So it is used in case of thermal power station, and where the much number of power can be generated, and the steam velocity is not very high in case of reaction turbine, therefore speed of turbine is low. It is mainly used in case of the small thermal power station, or in case of the gas turbine, okay, or captive power plant, the reaction turbines are used. Okay, that's all for today. Thank you.